Yes, we can see it.
Okay, thank you. Thank you, Elizabeth, for that lovely introduction. And as she said, I am going to be talking about our integrated chemical environment data resource. Let's see. And my slides are not advancing. There we go. Okay. So my group, as Elizabeth said, my group supports an office of the National Toxicology Program that focuses on evaluating non-animal methods for chemical safety testing. So I'm going to talk a little bit about that and about how our data resource satisfies those needs. And then if all goes well, we're going to do a walkthrough of the ICE site so that you can see how our documentation supports our users' needs. And you know, we might have, I think we'll have some time for questions and discussion at the end if you need it. I'm so excited that my talk is following Ingrid's talk, because I'd like to encourage you to think about the personas that might be using our resource and what stories they might have and how our documentation is trying to support and those user stories. So chemical safety testing is required by law in many sectors. Products such as pesticides, cosmetics, and household products need to be tested for toxicity or safety before they hit the market. And that testing is mandated by regulatory agencies such as the Environmental Protection Agency, the Food and Drug Administration, Consumer Product Safety Commission, and so on in the United States, and in analogous agencies in other countries throughout the world. And in this testing, we're looking at both acute and chronic endpoints. Acute endpoints being things like eye and skin irritation, poisoning, and allergic dermatitis. And chronic endpoints being things like cancer, neurological effects, and developmental and reproductive effects. Things that might not make you immediately ill, but can cause damaging effects when exposure takes place over time. And this testing has traditionally been done using animals, unfortunately, but we have made really important progress recently towards reducing animal use in this area. And the way this is done is we have developed test tube tests to replace some or all of the animal tests. We have made computer models to predict when chemicals might be toxic. And we do data reviews to identify opportunities where testing that has traditionally been done might not be needed. And just to illustrate to you how far we've come on this, EPA announced a couple of years ago that they intend to eliminate the use of mammals for chemical safety testing by 2035. So most of this testing, when you think about animal testing, it's done in rats and mice. And they have said that we're not going to do that anymore by 2035, which is huge. So this is my group, National Toxicology Program, Interagency Center for the Evaluation of Alternative Toxicological Methods, familiarly known as NICETUM. And we are, to be specific, most of the people that you see on that screen work for Integrated Laboratory Systems. ILS is a Research Triangle Park small business that provides preclinical and research toxicology services to government and commercial clients. And my office of ILS supports this office of the National Institute of Environmental Health Sciences in Research Triangle Park. So NICETUM, the collective government and contractor group, in turn supports an interagency committee made up of representatives of the Food and Drug Administration, the Environmental Protection Agency, blah, 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 that bring all the government agencies interested in chemical safety testing together to figure out how we can advance acceptance of non-animal methods for chemical safety testings. So we provide support to that group, and we also evaluate data for new methods for chemical safety testing to see if the test tube methods are as good as the animal methods. We develop computational approaches for predicting toxicity, as I mentioned, and we conduct data analysis to identify opportunities to reduce testings. And just to sort of brag on our leadership in this area, this gentleman, Kamel Mansouri, is one of our leaders in developing computational approaches for predicting toxicity. Nicole Kleinstroyer right here is the director of NICETUM. Both of them have received recognition and cash awards from Lush Cosmetics for their leadership in the area of supporting elimination of animal testing for cosmetics testing. So this is, so we're very proud of our work. I've mentioned the terms data and computation a lot so far in this talk, and that is what developing new methods requires, because to develop a new test tube method or new computational method, you need data from the new method, but you also need data, good quality data from the established methods to compare it to, as well as data from positive and negative controls test chemicals that have a well-documented effect on your endpoint of interest. And so another thing you want to do is, in addition to comparing the performance of a new laboratory method to an established method, you might want to combine data from several methods to generate a toxicity prediction. So if you think about what happens when you feed a chemical to an animal, or you treat an animal with a chemical, you've got a lot of things going on in that animal. And a chemical test that takes place in the test tube just might measure one of those things. So generally, to replace an animal test with a test tube test, you're going to need to run several different test tube tests that measure different things that might be going on in the treated animal. And you need a way that's computationally and biologically valid to combine that data. So that's another thing that you're going to use computation for in this context. And then, of course, predicting toxicity of a new chemical from what we know about similar chemicals. And there are mathematical ways to do that, as well as determining whether all currently required tests are needed. And so providing that data and those analysis tools that are needed to do all these things is what we set out to do when we developed and launched the integrated chemical environment in 2017. It's designed for our stakeholders, and it has data and lists of chemicals and tools that you can use to explore that data by running searches or running mathematical models. And then you can, it's got some resources to allow you to visualize your query and analysis results. And so, and I'm really excited. So these are our personas. we have a diverse user community that uses ICE. There's toxicologists, data scientists, regulators, and they're all going to be bringing their own user stories to ICE. And we are trying to provide documentation and resources that'll support those that are good matches for those user stories and help our stakeholders get their jobs done. Our stakeholders have very varying level of comfort with technology, and they all have tasks that they want to accomplish quickly. Many of these folks, particularly the people in the diverse agencies that we support through our interagency group, they have tasks that they want to accomplish quickly. They're evaluating alternative methods as an other duty is assigned. You know, they wear many hats, and this is just one of them. And so they have, they want to be able to get their work done quickly. And all this is going to be supported by good documentation. So now, if all goes well, we're going to go over to ICE. And do a live demo. Is everybody seeing the ICE homepage on with the its animated slider? That is everybody seeing that on their screen?
Yes, we can see it.
Okay, thank you. Great. So I'm going to go through, there are several types of documentation we provide for our users. And first I'm going to talk about what we provide on our web pages. So here's the home page, and you can see that you have access to the tools, and something that you can get to from the home page are a news page that tells us tells the user what's going on with us right now, what upcoming meetings that we're having. We're going to be doing demos and new feature demonstrations at. And we have release notes that tell you what has changed with ICE in the most recent release. We've got an about page that gives the new user an overview about what they should expect to be able to do in ICE and what data resources and tools are available in on the site. Frequently asked questions page, again, to help the new user get oriented to what they might be able to do and what the constraints of the site, limits of the site are. And a contact page. And so let's now go to one of the tools. This is the search tool, and it just allows you to ask simple questions about, answer questions about data that might be available in ICE for a particular set of chemicals or a particular toxicity endpoint. Every one of our input options has one of these little green buttons by it. If you hover over one of these little green buttons, we have a pop-up that says what that will tell you. And then if you click on it, it explains that for this particular input feature allows you to limit your scope, the scope of your search, whether it's to make it broader or more restrictive. So I'm going to go ahead and set up some chemicals and some assays for a search. This button's going to give me more information about how to select chemicals. And then when I go to my select chemicals window, each of these information buttons tells me something about the data set that, or the chemical list that I might want to choose. So we provide a bunch of canned chemical lists so that if you are interested in a particular endpoint, but aren't sure what chemicals might cause an effect in that endpoint, we can provide you a list to do that. So I'm going to select a list of 123 chemicals recommended for evaluating eye irritation assays. And I'm going to use that to set up my search. I'm going to select some assays that are also relevant to eye irritation. And then I'm going to run my search. And again, on the output page, we have some buttons that tell us this one explains what you're seeing in the data results table. This one tells you how to adjust the figure legend so that you can only see parts of the data that you're interested in. And then each of our graphical displays has a link to the Interactive Tools User Guide. And that's just a web page that I can't get to because, let's see. That's a web page that explains to you how to use all the features of our data visualizations. So if you notice that if I hover over this graph, a menu pops up at the top right corner. It explains how to use all those tools that you see in the corner. So we have, so I'm going to leave search now and just click briefly on this page that shows you the other tools that ICE has available. And each of these, the search tool and each of the other tools has its own user guide. And the user guide, so this is back to the search tool that we just visited. And the web page has a brief overview of how to use the tools. And then if you want some more detail, you can click that button. And this is a detailed downloadable user guide that has screenshots and walks you through exactly how to set up a query and what you might see when for the query results. It has a list of all the abbreviations that you're going to see. I live in acronym land, folks, and we use a lot of abbreviations. And so I want to make sure that those abbreviations are comprehensible to people. And it has an appendix explaining some of the terms that we use within the context of ICE. And then our acronyms are also explained by little pop-ups in the on the web page text. So you don't have to go to the user guide to get the acronym definitions. You can just hover over the pop-ups on the web page. In addition to the tools, we also, I mentioned that we have some canned lists of chemicals, and we provide some documentation to those too. So this is a list of all the our canned chemical lists. We call them chemical quick lists. And if you remember our search query, we ran a search query using the eye irritation corrosion chemical list. We can learn more about that list by going to our chemical lists page and clicking on this button. And it tells us how that list was compiled and what information that list would give us. or we could just download the list. And I meant to do this before I started, but let's see how long it takes to open. Yep, there it is. So this is the list of chemicals that we ran our query on. And it has information about, hazard classifications and other endpoints that are relevant to eye irritation. In addition to the chemical lists, we also provide our users information about data. We have some specific criteria that we use for including data or not including data in ICE. We have a procedure that we use to process the data, and we have that all explained here. And then we also have the actual data sets that you can download with the like with an Excel spreadsheet, or we've got a web page here where we explain exactly where our data comes from and what kind of data that it is. So if an assay is measuring eye irritation, then this is how the animal. So this is a set of animal data that is relevant to eye irritation, and it talks about how the eye irritation is measured and how it's classified according to various classification schemes. So, so I'm going to go back to my PowerPoint now. All right, so all of this documentation, ICE has evolved very organically, and there's been a lot of, we launched it originally, we asked our stakeholders for feedback, and we got a lot of, well, I think it should be done, I think this should look like that. And why doesn't the tool do that? And can you provide me with this feature? And so we've responded by continually improving both the tools and the data itself, and the documentation goes with it. We get that input from our own leadership, from our federal agency partners, from the scientific advisory of the committee, of the interagency committee we support. Our scientists have a lot of collaborations going on with EPA and FDA and US Army scientists and so on. And, just all our other users, they all give us feedback and we listen to all of them. And this feedback gets implemented in updates that we release 2 or 3 times a year. And, as you might imagine, they're often driven by professional society meeting dates, because we want something to be able to, something new to be able to show to people when we go to these meetings. The updates may include additional new data or chemical lists, and development of new tools or improvements to existing tools. And there's a little graphic that shows you our the release cycle that we use for our updates. And so we start with a work plan, we develop data, we develop tools and chemical lists. We have a preview where we have some, a group of designated users that have agreed to give us feedback about, to preview the release and give its feedback. We do final web edits and updates of the downloadable user guides, and develop news release and promotional materials. And each of these steps that have a star by them those are the steps that I'm very much interested in, involved in, because I'm the documentation lead. This involves me working with the subject matter experts to develop documentation for that aspect of the release. And so when we're doing a release, documentation specific activities could involve a full site proofread and corrections made as needed, development of new text, revision of existing text, including the replacements of the screenshots in the PDF user guide if the user interface changes, and development of homepage graphics and news articles. And as the documentation lead, I'm going to work with any or all of the release manager, another technical writer editor, a subject matter expert for the tools being developed, and subject matter experts for the data sets or chemical lists. And I think we're doing something right because we've gotten a lot of positive feedback about our documentation. The Scientific Advisory Committee that gives us feedback on our work commented that they are very impressed by the thoughtfulness that has been given to the anticipated needs of the users. Music to a technical communicator's ears, man. And I just was so pleased that we, in the last year's Society of Technical Communication Carolina chapter document competition, ICE won a distinguished award, and some of the comments talked about how it's how easy to use our website is, how easy to read the user guides were, and what a pleasant experience that the interface provided. So, so that we were all very happy about that. And I'm just going to close by thanking my colleagues and just noting the diversity of people that that contribute to this effort. Our management and project leads steer our ship. The release managers are the project management focused people who get the release from start to finish. We have people who focus on data. We have people who focus on tools, and we have some technical writer editors that help me out with the documentation. And that concludes my talk. I would be pleased to take any questions. And if you are interested in this, ICE is a freely available public web page. There is no registration or no, we don't need anything from you if you want to go in and explore it. Just go to icentp.nihs.nih.gov and start playing around with it. And thank you for your attention. I'll be glad to take any questions.
Thank you so much for taking the time to talk to us about this. I appreciate it. Did anyone have any questions?
I'll go ahead and stop sharing now.
So I'm not sure that you got a chance to talk about this too much, but, and you might have, maybe you could expand on it a little bit. Where did the idea for ICE originally come from?
So, short answer, the previous director of the National Toxicology Program office, so let's see. So toxicology, and so I've been working with my group for about 14 years now. And in that time, the science of toxicology has really moved to a science that is very computationally and very data focused and very data driven. And we sort of, we identified a need for a resource that was very focused to the kind of questions that regulators might ask, because those are one of our key user groups or key stakeholders are regulators that are trying to decide whether, I've always used the rabbit test for this to test this toxicology endpoint. Now somebody's come along and has a cell culture test that claims to be able to measure the same kind of toxicity. Is it as good? Can I trust this new method to keep people safe? And so our resources designed to help people keep those, make those kinds of, answer those kinds of questions. And so it was, so our group, or the federal agency, the federal office that I support, decided that they were going to devote some resources to developing this kind of tool that that could help other federal agencies answer these kinds of questions. So this is a publicly funded effort, and my office my group spends about 40% of its time and effort on this, on improving and supporting its research. We also do other projects like evaluating new methods and things like that. But this is one of our big projects. So does that answer your question?
It does. Thank you.
Okay, you're welcome.